Good evening, sir. Again, we will start the continuation. Important factors to consider while the taking care of the circuit design or the taking care of electrical designs and all these things. Wire gauge to be taken care of, not only in industrial but also the household wires also will be taken care of. Insulation tape as already discussed. Termination methods where we have to see that the isolator cannot isolator will be red button will be pushed up, but the isolator cannot be stopped. But that is also be taken care of. Switchgear designs is there. Choosing suitable switches and circuit breakers with appropriate interrupting capacity of the circuit. Where the switchgear unit is there, immediately electrical circuit breakers is there. Immediate tripping is necessary to indicate where the high voltage sensor is there. You have to see that high voltage current or high voltage or high current is there. You have to have a facility to switch gear or to regulate the voltage or regulate the current flow and all. We have to see that properly designed. In the examples of applications here is these are things to be like for example wire gauge, insulation tape, and termination method. Switchgear designs are household wiring also to be taken care of. Selecting the wire gauge, that wire thickness also for various applications in the circuit breakers also. Sometimes in the household also we also main control board MCB switch is there and fuse is there. If any electrical supply is there, first of all we have to take care of the first the MCB will tripped if the stabilizer of the equipment is there. If the stabilizer of equipment is not there, even then it will go to the fuse, main fuse in the panel room. It will be there. When fuse condition is not good, electrical earth condition is not good, then definitely it will damage the equipment. So we have to see the where the electrical leakage is there. That will be taken care of. The various controls like fuse, MCBs, electrical circuit breakers, and the we have discussed in the coming residual things also will be discussed in the coming slides. Very important. The household where is also not the connectors like circuit breakers, but we have an MCB main control board is also there apart from the cellar panel boards or the apartments and that. Industrial power distribution is very important. How the distribution circuit diagram is the in the electrical panel room will be taken care of display also. By all the electrical engineers should know how the electrical power distribution is there in industrial wide. After reaching the APS, CPR, what is called the state electricity boards supply from the 33 kV by 11 kV transformer step down transformers, and 11 kV reaches to your end, that is our nation end. Thereby, 11 kV reduces to the 440, and then 440 reduces to the 230 also. Some like in circuit breakers and other panel rooms need some 440 volts, and some household or the organizations having the switchboards 230 volts. 440 volts requirement is there, and the 230 volts requirement is also there, where the source is also very important and the receiver is also important, and path control is also very important. Apart from this, we have to see that industrial power distribution circuit diagram should be displayed in the electrical panel room or in the electrical office rooms and all these things. That electrical engineer should ensure that everybody knows about the power distribution throughout the organization. The motor control circuit emergency MCC is there, where it will be helpful for the where the high voltage is there or low voltage is there. The MCC will be taking care of the equipment. It's very important motor control circuit. Proper selection conductors, termination methods, motor starters, and control relays will be taken care of. These are the examples of applications of these things to be taken care of in the applications of the wiring and all these things, electrical works. Before going to this, overload and the short circuit protection and no load protection, very important. Overload, short circuit protection and low load protection. Here the overload and short circuit protection refers to safety mechanism in an electrical circuit design automatically cut off power when the excessive current is drawn due to either a heavy load or overload, or a direct connection between the live wires and the short circuit. So the overload is one part where the high voltage is suddenly received. One part is there, we have to taken care of. Where the no load protection is also there, where the turbine is having some problem is there in the some other sections. The turbine power is not necessary for the time being. We have to slow down the turbine rotation power also. At that time, the sometimes what is called in a because of the some shutdown before starting the resuming the shutdown, the preventive shutdown or maybe the annual shutdown. Before starting the shut or resuming the shutdown, you have to immediately start the turbine. It takes some time to run into the circuit. That's why the no load protection will be there. It will run after uh, many hours, then it will taken the load on the turbine. That's why no load protection is also to be provided through MCC for any equipment. Sometimes when the critical motors are there, we cannot stop and off and on the various 450 HP motors like chipper house motors or where the heavy load motors are there, HP motors is there. We cannot have simply switch on and switch off. We have to have a provision of overload tripping and provision of load load protection is also there. Where zero load is there, where the current is not drawing that meter, but even then the motor is kept running. Immediately, whenever we need, immediately start the correction. Current will be given and no load protection to the loaded protection will be there. That means both sides we have to see. Overload and no load is also taken care of. In this regard, we have to see that how the current flow is also very important. That's why the key points in with respect to the overload and short circuit protection, no load protection, and all this thing. Some key points to differentiate or to keep in mind by every electrical engineer or any electrical supervisor or any electrical experts also. Overload protection, circuit protection, and the no load protection. These are the very, very important areas to keep in taken care of while designing the circuit or while purchasing the equipment. Whether the equipment is having the inbuilt capacity of the overload tripping is there, or the any earth leakage is there, it will give some alarm immediately to take care of the saving of equipment. Like this, some facilities will be there for the electrical equipment, and we have to see that before purchasing any electrical equipment, we have to see that all the facilities is there or not. First of all, all road protection activates when the current exceeds the normal operating limit for a sustained period, usually due to heavy load on the circuit. Definitely, it becomes an overload on the equipment. Suddenly, apart from the higher than the normal operating limits, sustained period is there. For example, long period is there, or the limited period is there. Okay, for example, but long period is there when the exceeds the normal operating load. Definitely, it becomes a treat as a overload circuit, and we have to see that immediate tripping is there to be taken care of the to save the equipment apart from the productivity, apart from the production taken care of. But we have to see that electrical is very dangerous than the product selling out without seeing any product damage and all. Maximum attempt we have to taken care of. But where the electrically there is a hope to damage the equipment is that immediately we have to sacrifice the production also with respect to the safety of the equipment and safety of the employees working nearby that equipment. That's why overload protection is always there with any equipment where the overload is there immediately tripping. Sometimes what is called the thermal mechanism, there is a position is there. Often uses, sometimes uses the thermal mechanisms like bimetallic strips in circuit breakers to respond gradually to sustained high current. Where the high current is there immediately not taken by the damage of the equipment, In that reason, to save some time, bimetallic strips also will be taken care of in circuit. Bimetallic means two metals of strips will be there to withstand the high current and high voltage also. These are the overload protection will be there for any electrical equipment is there. Short circuit protection is also important. Where the short circuit is there, immediately ELCPC is there, electrical leakage or electrical circuit breakers is there, immediately breaker will taken care of the equipment to save. But we have to see that circuit having a protection. That means circuit itself is inbuilt in the equipment. Any high power is there, or any short circuit is there, or electrical leakage is there, or the earthing is not proper. You have to see that that indication will be given by that equipment signals. Therefore, the electrical engineer will take in some precaution steps to save the not only save the employee safety but also save the property damage of the equipment or property damage of the organization. Acts very quickly to cut off power when the direct connection is made between the live wires and causing the sudden surge. Surge means sudden increase of voltage, sudden increase of current. Even in the what the state electricity board having the main control boards panel room, operator normally sits before the operating before the panels, where the some areas in the towns in the from 6 o'clock to night 11 o'clock, where the high load is there, immediately switch off the that area and given some time to pick up the or to avoid the danger from overload. That's why we have to see the immediately very quickly power the circuit is there. That provision is there in the circuit diagram also we have to provide. Typically employs the fast acting mechanism like fuse that melts rapidly in case of short circuit. Normally, what happens? So many people are thinking that the fuse, if you have what is called three numbers of wires or three numbers of strips, wire strips will be taken care of. It will taken care of what you call the withstand. No, in fuse very small, very number of strips will be three or two only. We have to keep in fuse. Normally, people are putting six numbers of wires and taken care, and they will put the electrical fuse strong. No, electrical fuse should be very weak. Whenever the electrical circuit breakdowns is there, or the electrical circuit leakage is there, or overload is there, or high voltage is there, high current is there, immediately fuse will be cut off immediately. In such a way, the fuse is very sensitively you have to manage, but number of now people think that fuse to be strong, equipment is strong. No, fuse to be very weak, and we have to see the strip of the wires where we have to keep the terminals in the fuse, very less number of wires to keep it. And every electrician knows, but common layman should know about this condition also, fuse conditions also. So no load protection, very important here is, as I already told, where the turbine is there, where the load is not there, we have to keep in. After the resuming of the shutdown activities in the organization, we cannot start immediately like a motor, switch off, switch off, switch on, like a turbines and all, like a motor. Turbine, we cannot like this. First of all, we have to start the turbine and see that no load protection is there. And after the loading, then again will be taken care of into circuit. Before that, no load protection is also there for the circuit. That's why the what we call the design and to detect the situations where the current draw is significantly lower than the expected. Here it is exceeds the normal operating limit. That is overload protection. Here the current draw is significantly lower than expected. That's for 440 volts is there, but it is drawing on 230 or 200 only, but it's a low, significantly low. At that time, no load protection is there for the equipment. Definitely, it will be taken care of the problems like disconnected load and all these things. May use the current sensing circuitry to monitor the current level trigger protective action when it falls below the preset threshold. That is why in the low load protection, overload protection is very, very important. It is higher than expecting and lower than this. both facilities to be taken care of in the equipment. That's why we have to install a motor MCC designation, which has that motor control circuit, that is called motor control. A motor controller might include both overload and no load protection features. When the motor is overloaded, the overload protection would trip. While if the motor is running with no load at all, that means the no load protection could activate to prevent the potential damage from the prolonged operation under such conditions. Therefore, the MCC is always helpful for the equipment to see that be taken care of sometime, and no load also can be taken care of for some time, but not a prolonged operations. The prolonged operations, no load protection could activate the prevent the potential damage. See, the important word is the no load protection could activate to prevent the potential damage from the prolonged operation of the under such condition. So even no load is there, prolonged the shutdown is not after the shipment, some activity is not started, the burn furnace, boiler and all, the turbine requirement is more than expected schedule. Instead of 10 o'clock, they need 11 o'clock, 12 o'clock, 2 hours delayed. Therefore, at that time, the turbine kept under the no load protection for a prolonged time. That also to be taken care of the MCC. That means motor control circuit will be taken care of. All the controls before designing or before purchasing the equipment, electrical equipment or not, we have to see. But also the very important points is key points about the earth fault protection. Where the earth leakage is there or the earth protection is not proper, there are two things we have to see, keep in mind. Earth leakage circuit breaker, that is ELCBs, and the residual. And recently, the organization is going for the, instead of going for ELCBs, and they're going for the RCD, which is more cost also than the ELCBs, but going to the RCD only, where the residual current will be taken care of. For example, earth leakage circuit breakers, a common household device that trips the when a significant local leakage current is detected. Leakage current is, that means where the earthing is not proper, there should be some where it placed leakage is there. Why it goes to the first earth? High voltage is there. Everybody knows that where the voltage difference is there, current flow is there, definitely. The supplying of the state electricity board, supplying the 230 volts to our household electricity, they taken care of the fuse, taken care of the MCB, taken care of the equipment stabilizer, and the equipment to the equipment run in the household like washing machine. For example, where the high voltage is there, MCB is not proper, for example, stabilizer is not proper, for example, fuse is not proper, immediately it will go to the earth leakage. Why earth is going? Why the current is high voltage current will be going to the earth itself? Because earth potential is always zero. Where the voltage difference, your supply is over 230 volts, where the earth potential is only zero, definitely where the low is there, 230 minus 0 is 230, it will go there only, earth. That is why earthing is very, very important for any electrical circuits. Where the earth potential is zero, that's why where the high voltage or high current is there, definitely to go to the without damaging the MCB, without fuse cut off, without damaging the equipment stabilizer, without damaging the equipment. Therefore, it will go to the earth only. That means earth is very, very important is there. For that, we have to see that ELCBs and the RCD, residual current device. Recently, it is developed similar to an ELCB, but with higher sensitivity to detect the small fault currents. In a ELCB, electrical leakage circuit breaker, where the small currents leakage is there, maybe the electrical circuit breakers may not work sensitively and the faults are very smaller wise. That's why their design is now a residual current device is also there, where with higher sensitivity to take these smaller fault currents also. Here, the smaller fault currents will not be taken care of, not that much of sensitive when compared to the RCD. That's why industries are going for the residual current device, even though cost is more. But normally people are putting some of the organizations where the healthy organization is there in the financial, they'll put both also, where it can taken care of the ELCB where the voltage leakage or significant leakage is there. Very smaller leakage also it will function immediately. Both are not at similar or same function at the same time. First of all, ELCB will work. The ELCB is not work with the smaller voltages, then RCD will be taken care of. Only will RCD taken care of, only RCD will be installed in the circuit. Definitely both will be taken care of. High voltage and low voltage also, low small faults also. So the protection device is also very important. ECBs and RCDs, residual current devices. The earth insulations and continuity tests. The why the earth insulation is necessary to verify the integrity and the earthing system by measuring the distance between the conductivity parts equipment and the earth. Because I know I already told the earth potential is zero. The voltage difference is 230 minus 0, 230, it will go to the earth. What are the test methods are there? Whether your earthing mechanism is working perfectly, or ELCB is working is good, or RCD is good. How do you test it? We cannot, what is called, wait for the electrical circuit breaker to trip, or we cannot wait for the the residual current device to trip, to work or to function. But before that, we have to earth resistance test, loop impedance test, and the continuity test. These are the three facilities where the earth insulation and continuity test is there. One is earth resistance test is measure the resistance between the earth and electrode and the surrounding soil. You have to see that whether the earthing facility is done at your place. The soil conditions also we have to see that earthing resistance test also measure the resistance between an earth electrode and the surrounding soil. The surrounding soil also will be see the condition where the wet soil is there or the wet condition of the soil is there nearby. It is not supposed to be allowed to the. That's why the resistance between an electrode and the surrounding soil also will be taken care of. That's why if the earthing facility is there, some small cement dip dig is there, you have to see that it will be earthing facilities will be definitely properly. We will be discussing the coming slides also how best we can provide the earthing facilities also. Loop impedance test. Measure the total impedance of the fault loop, including the resistance of the earth conductor. There is a loop test is there where the connecting to the resource and the receivers, and we have to have in between the path control meter is there. If it gives the what is called very sudden impact is there in the voltmeter or in the current meter and all this, or the megger meter and all, you have to definitely, we have to see that there is a chance of leakage of the current or high voltage, or the leakage of the current or leakage of the voltage through MCB or through fuses, to allow, not to allow for the through fuses and through MCB, but it's allow through earth only. That impedance test will help the earthing should be made properly. During that time, you have to see that the current will be off and make the earthing facilities will be properly, and see that the resistance to the earth conductors properly work. What we have to see, the earth having a potentially zero because of the potential, earth potential is zero voltage. Therefore, all the leakages, it should go to the earth only. Therefore, saving of the employees, saving of the equipment, saving of your appliances like MCC, you have like MCP, and equipment damage, and the equipment damage also will be controlled. The continuity test is also there. Checks continuity test of earthing conductor by measuring the resistance. That's why the resistance will give the value of the resistance will give the whether that thing is healthy or not. That's why the continuity test between the receiver and source. We have to see that these are the three test methods will be taken care of. Another earthing standards. These are the two standards are there to provide a guidelines for the proper earthing system design and installation, specify acceptable resistances, values, and testing procedures. These are the two standards are there. IEC 60364 International Standard for Electrical Installations and the BS 7671 British Standard Electrical Installation. Here the one legal requirement is there in this where it is not mentioned here because it is not the context to mention on this with this standards. Electrical Act 2003 also it will be helpful for going to the parallel verification. Electrical Act 2003 standard also will be taken care of along with these two also. The protection against the surges. Surge means I already told sudden leakage of the current or voltage or the protection against the surges and the voltage fluctuations is there. High currents, high voltage fluctuations is there, for example. Surge protection devices, SPDs we call like surge arresters and transient voltage suppressors, that means TVSs. Because the already told source, path control, and receiver. These three things are very important to mention in the electrical field. Therefore, the surge protection in that line, surge protection devices, surge arresters are there, devices designed to absorb sudden voltage spikes caused by a lighting strikes or switching transients. Suddenly, if you have a overload, yeah, immediately you have to see that suppose if a long time kept the household circuit is shut down, you came from outside and open the circuit once in a while. You are coming to the house and all switches off. One you switch on means it gives the overload. Devices designed at that time, devices to accommodate any overload protections is there, any overload spikes. That means not a sudden a fraction of seconds. It will give overload voltage or overload current is there. At that time, surge arresters. That means devices designed to absorb sudden voltage spikes caused by lighting strikes or switching stunts. Where the lighting strikes means where the tube light or your light source is not good, even though your receiver is not good, but source is good. Receiver is not having the potential to take care of that immediately. The difference between the source and the receiver is difference is there. Definitely, voltage spikes will be taken care at that time. The such devices will be taken care of immediately. Will act and see that the equipment will not be damaged. The transient voltage, while the path control will be taken care, the electricity will be taken care of, used to protect sensitive electronic equipment from smaller voltage surges also. Here the any voltage difference is there, it will be immediately such resistors will be functioned. But where the small difference is there in the voltage or small, not prolonged time is also there, like already told ELCBs and the RCDs will work the surge resistors as well the transient voltage suppress also. These are the more sensitive control than this. It will be having less cost. This is having the more cost because the smaller voltage fluctuations also will be taken care of. The transient voltage suppressors. It will suppress the where the spikes is there, where the difference of the fluctuations is there. It will suppress immediately. Whereas it is arresting immediately. It will arrest, absorb sudden voltage. It is only where the smaller where the differences will be could be reduced to smaller one. Therefore, here the circuit break or the electrical device or electrical circuit will not stop here, but here the in the surge resistors electrical will be stopped. That's why the TVS only suppress. You have to reduce the voltage fluctuations. Key points to remember: a good earthing system, regular testing, and different types of this thing. See, these are things will be already discussed with test methods. and the regular testing method, and different types of earthing methods are there. The functions is there, already discussed in this. If you see a good earthing system will feature the following seven characteristics: is good electrical conductivity, conductors capable of withstanding high fault currents, long life at least 40 years, low ground resistance, impedance, and the equipment equipotential bonding, good corrosion resistance, electrically and mechanically robust, reliable. These are the good earthing facilities to be taken care of to safeguard your equipment, to safeguard your the employees, to safeguard your electrical appliances like spare parts, ELCBs, and RCDs, switch gears, and such gears, and TVS, and all these things will be see. These seven characteristics will be taken care of before taken into the any electrical equipment or to purchase. If you see the characteristic of the good earthing system is there, where the electrical will be there, leakage will be there, earthing pit will be there here. This is the earthing pit. Where in that normally one of the what is called recently it is coming years back one ground enhancement material called gem, where this is called gem, where we are putting this gem materials is there. Definitely the soil condition is suppose in case the soil condition is not proper, we have to use that gem and the layer and all, and then stand and then jump and then sand. Like this, then we will be protecting of the your earthing insulation system. That's why it is superior conductive material that solves your toughest grounding problems. Where the loose soil is there or wet soil is there in the earthing conditions, definitely the jump of the this powder system like a tar, it will have what is called like a cement powder, like a, what is called in the liquid form, it will be helpful to see that the earth soil conditions should be taken care of. It is the ideal material to use in areas of poor conductivity, such as rocky ground, mountain tops, and sandy soil. See, for example, this gem will be used for where the soil condition is not good or not encouraging. That's why it's very important. A superior conductive material that solves your toughest grounding system. That means it is the ideal material to use in areas of poor conductivity, such as rock ground or rocky ground or mountain tops and the sandy soil. Already told the sandy, the soil conditions should be very encouragement is there for the earthing facilities. That's why we have to use this gem material, that is ground enhancement material we called as a gem. And coming to the some representation is below picture shows that earthing system incorporated into an electrical system is there. Here the lightning arresters we will be discussing in the next sessions in the next week. Lightning arresters also will be taken care of. In this, the isolator will be there, electric service board, where the earth wire to be connected to this system. These will be taken care of here and there. Earthwide, soil earthing electrode, backfill compound, fault, and these are current anticipation. These are the will be taken care of the when you are making care of the earthing portion shelter. So the types of many earth conditions is there will be taken care of. The various guidelines are there for the earthing of the ensuring safety electrical systems. It will be helpful for taking care of the uh, uh, even if you are not encouraging the soil condition, make the soil is fit by using the jump. That's why in normal, all the people are using the where the very sea coastal is there, where the sea coastal nearby, the house construction is there. Definitely, earthing soil condition is very weak. At the time, the gem material will be used for the earthing facilities, where the sea coastal is nearby or river coastal is nearby. The water table in the ground level very nearby. Sea coastal or the river people river nearby